Hello everyone and welcome back. My name is Mr. Kovalt, and in this video we're going to show you how to draw 3D pictures showing the bonding of molecules, and we're going to point out sigma and pi bonds. So let's get started. So in this problem we're told to draw 3D pictures showing the bonding in the following molecules. Your picture should clearly show both sigma and pi overlaps of orbitals. Label all sigma bonds and pi bonds. Okay, let's get started. Okay, so for number or letter A, we got N2. So we need to know what the Lewis structure for that. So if we draw the Lewis structure, you'll get this. And so right away from the Lewis structure, you could see that the bonding between the two nitrogens is 3 bonds. And so one of those bonds is going to be along the axis. We call that a sigma bond. And then the other 2 bonds are going to be outside the axis. They're going to be overlapping of orbitals on the outside of the axis. And we call those the pi bonds. And so how would we draw this? So first, a little caveat, I'm not an artist. I'll do the best that I can to show you what a three-dimensional drawing might look like. But I'll kind of talk you through it, and so that way you understand what I'm drawing. So I'm going to use different colors. So for the nitrogen, I'll use black, and then we're going to have, notice here we have 2 electron groups. The triple bond is treated like single and double bonds when it comes to counting the number of groups. And if you remember, the number of groups will determine the hybridization of your of the orbitals that are overlapping. So here you'll see that this nitrogen has a lone pair and it's bonded to one atom, the other nitrogen. So that's got 2 bonding groups, and so 2 groups total. And so for the number of groups, you need that many atomic orbitals to hybridize. So just I'll write down here. So we're going to hybridize the atomic orbitals. So we got 1s, we got 3 p's, and we got 5 d orbitals to work with. So we only have 2 bonding groups. We only have 2 electron groups total. So we're going to need 2 atomic orbitals to hybridize together. And then remember, what the number you put in is the number you get out. So if I take 2 atomic orbitals, s and p, you always work your way from lowest energy orbitals to higher energy orbitals. So we need 2 orbitals. So we're going to use the s and the p. And so we're going to hybridize those together. Since we're taking 2 atomic orbitals, we're going to get 2 equal energy hybridized orbitals. So this is going to come together to form 2 sp hybridized orbitals. And so the nitrogen here, both nitrogens actually have 2 sp hybridized orbitals. Okay, so then this lone pair and one of the bonding electrons are going to go into each of the hybridized orbitals. So then you're going to have an sp hybridized orbital that way for this nitrogen, an sp hybridized orbital that way, and this nitrogen is the same. So there's going to be an overlap here of an sp hybridized orbital, and then over here you're going to have an sp hybridized orbital, and in here you're going to have the lone pair electrons like so, and then of course you're going to have an electron pair there, right? So being shared between the nitrogens, and then you got the lone pairs here. So we've got our sp hybridized orbitals, but what about the pi bonds? Pi bonds are formed from unhybridized p orbitals. And if you remember, p orbitals are perpendicular to each other. So remember, we have the axes, right, like so. This is our z, this is maybe y, this is x. And then you have the unhybridized p orbitals that are along these axes like so. So they're all perpendicular to each other, right? The y and the z and the x orbitals are perpendicular to each other. So that's going to be important to keep in mind when we're figuring out the shape of this, right? So here, I'm going to use a different color. I'm going to use orange. So if you have unhybridized p orbitals, they're going to be perpendicular to each other along at the center with the nitrogen at the center, right? The nucleus is at the center here. So then it's going to be perpendicular. So here we have along the axis, so this is our sigma bond, so we'll go ahead and label that. Well, I'll label them later. Okay, so then I'm going to have an unhybridized p orbital perpendicular to the plane here, perpendicular to the axis. So I'm going to have an unhybridized p orbital. And then on this nitrogen also is going to have an unhybridized p orbital. So that's going to be perpendicular. And what creates the pi bond is the overlapping. So they got to be in kind of same space, right? So this is on the bottom, this is on the top. They're close together. So this is going to form a overlapping here and overlapping there. So then you've got your 2 electrons in there, right? And then I'll use blue this time. So then you also have a second pi bond that comes from the overlapping of another couple or another 2 unhybridized p orbitals on the 2 adjacent atoms. So again, this is where your artistic abilities are going to come in. Mine, just bear with me. So since this is perpendicular, I'm going to draw the other one so they're perpendicular. So it's going to be on the sides. So the way I'm going to draw it is so the blue is going to kind of go this way and kind of go out this way. So you can imagine that this is going left and right. And so again, this nitrogen is also going to have perpendicular unhybridized p orbitals. And so if you can kind of imagine that these are on the top and bottom, the orange is on the top and bottom, the blue is on the left and the right. So if these are going to overlap, they're going to overlap like this, and this is going to overlap on this side. So you can kind of see, hopefully you could see that as being perpendicular. So this is on the one side, right? If I'm standing this way, this is going to be on this side, and this blue on this side is going to be on the opposite, going into the board. This is coming out of the board. And so these are going to be perpendicular to each other because why? The p orbitals are perpendicular to each other, and we have unhybridized p orbitals that are overlapping with each other on each side, each atom, right? So then that is kind of how you would draw your three-dimensional picture of this molecule. As far as the labeling goes, so here and here, you have your sp hybridized orbital, and that's going to be your sigma bond. So this is small letter sigma, Greek letter sigma. So that's your sigma bond. So this is going to be your sigma bond, right? And so here, let me draw this. So So your sigma bond is here. You got your sp hybridized orbital here. You got an sp hybridized orbital here. Let me draw that here. So sp hybridized. And then you got your unhybridized. So then this is going to be your, oops. This is going to be your pi bond. Again, that's the Greek symbol pi. So this is your pi bond. And then the blue here, this overlap is going to be your pi bond as well. Okay, I hope that's helpful. Okay, so I've kind of ventured into my space here. So now I'm going to draw the Lewis dot structure for this molecule. So what's the Lewis dot structure? It's going to be C double bond O. You've got 2 lone pairs there, and then you've got your hydrogen and your hydrogen. Okay, so now that we got the Lewis dot structure, you can see that we're going to have a sigma and pi bond here because you got a double bond. Anytime you have a double bond or a triple bond, one of those bonds is a sigma bond automatically, and then any extra bond you have are going to be automatically going to be a pi bond. So here we're going to have 1 sigma bond and 1 pi bond. And so when we write draw the picture for this, again, I'm going to use black for the main. So here we're going to have carbon and then the oxygen. And so the oxygen has 3 groups around it. So the double bond and these 2 lone pairs. So that's 3 groups. So in that case, we're going to have an S, a P, and a P. So that's going to give us 3 hybridized sp2 hybridized orbitals, molecular orbitals, right? So if I draw that, it's going to look like this. So I'm going to have that there. That's going to go that way. And then I have this one going this way. So this is going to be trigonal planar. These are going to be in the same plane. So there's my these are my lone pairs. And then the carbon here is also going to be sp2 hybridized because this has 2 bonds, 3 bonding groups, 1, 2 single bonds, 1 double bond. So again, sp2 hybridized because you're going to take an S, a P, and a P. You got 3 of those. And so you're going to hybridize those into 3 equal energy sp2 hybridized orbitals. And so for the carbon here, then you're going to have an sp2 hybridized overlap there. And then these 2 are going to be also going to be trigonal planar. So then I'm going to have my hydrogen. Now the hydrogen here only has 1 orbital filled. That's going to be the s orbital. And so that's going to be an unhybridized s orbital. So that's going to have just this spherical or circular shape to it, and that's going to be the hydrogen, right? So the hydrogen, how do I want to draw that? So in this case, if I redraw this a little bit. So these are my hybridized orbitals, sp2 hybridized orbitals. And so I'm just going to represent this as a circle for the hydrogen. So then we got our hydrogen here, right? So here we have sigma bonds. Why? Because again, sigma bonds are overlaps along the axis between the atoms. So you have here a hydrogen unhybridized s orbital overlapping with a hybridized sp2 hybridized orbital on the carbon. That's going to be hybridized, or that's going to be overlapping along the axis directly between the atoms. So that's going to be these are going to be sigma bonds. So if I draw, let me label this. So these 2 are going to be sigma bonds. Okay. This also, because it's directly between the carbon and the oxygen, that's also going to be a sigma bond, right? So far so good. And so now we have to deal with this double bond. Remember, double bonds mean you have one sigma bond and then you got a pi bond in addition to that. And the pi bond is the overlapping of unhybridized p orbitals. So now, how are we going to draw the p orbitals? So since this is in the same plane, right, and this is also in the same plane, so the pi bond is going to be perpendicular to the plane here, right? So if this is in the board, then that means that the pi bond has to be coming out of the board. So it's going to be perpendicular to the plane, just like the blue one here. So the blue one is supposed to be coming in and out of the board, perpendicular to the board. I tried to write that, in this perspective. But again, I'm not an artist. So I'll try again here. So the pi bond is going to be sticking out of the board. So we're going to have, let me see, let me use orange here. I think orange might show up clear. So here, this is going to go into the board. This is going to, oh, that doesn't look good. Let's try that again. That's going to come into the board. And then you've got also, let me make this better. And so then you've got also here on this oxygen, there's going to be an unhybridized p orbital there. And again, you got the other part coming out here, right? So the orange here is going to be coming out there. It's going to be coming out there. So again, I'm trying my best to kind of draw this. So then this is coming out of the board. These two are going in the board. So you're going to get overlap here and here. And so if the molecule is this way, right, is flat in the plane of the board, then the orange is going out of the board like this. So this is going left and right out of the board. So that's, again, the best I can do with my abilities as an artist. So if we're going to label this, we're going to label this as a pi bond. So this here is going to be a pi bond. Okay. And we labeled this as a sigma bond. So we have our sigma bonds labeled. And so that is going to be, it looks like it's going to be a planar molecule. Okay, let's see. What's next? Next is C. So this one here, again, gonna stress my artistic abilities, but I'll do the best I can. Now here I have two double bonds. So this carbon here is double bonded to this carbon and this carbon. And so I have a pi bond here and a pi bond here. This carbon is involved in both bonding. So if I look at the structure here, let's go ahead and draw these three. So I'm going to draw this carbon and this carbon and this carbon here. Now, again, we're going to have sigma bonds here. So what this carbon is going to have has two bonding groups, no lone pairs. So it's got a total of two. So we're going to take the S and the P, hybridize those together. We're going to get two sp hybridized orbitals. right? So then this is going to be an sp hybridized orbital. And this carbon and this carbon are exactly the same structure. So same bonding pattern. So this carbon has 1, 2, 3 bonding groups, 3 groups total. This has 3 groups total. So there we're going to have to take an S and the P and create sp2 hybridized orbitals. And we're going to have 3 of them. So then that means that I'm going to have, again, orbitals, hybridized orbitals coming out here and then overlapping there, right? So here's going to be an overlap of an sp2 hybridized orbital with an sp hybridized orbital. And then same thing with this one. So I have here hybridized orbital, and then this is going to overlap with the orbital there. So then, because these are along the axis, those are going to be sigma bonds. I'll draw those in a moment. And so then what about these hydrogens? The hydrogens, again, just like over here, have just one unhybridized s orbital. So that s orbital is going to overlap with the sp2 hybridized orbitals of the carbon. Okay, I'd label the hybridization, but they don't ask you to, and it's going to get messy. So I'll just leave it at that. So here then is going to be an s orbital overlapping there, an s orbital overlapping here, s orbital overlapping there, s orbital overlapping there. This is where your hydrogens are, right? This is the hydrogen. Okay. Now, that means that because we have overlap along the axis between the hydrogen and carbons, those are also going to be sigma bonds. So we have a sigma bond here, sigma bond here, sigma bond there, there, and there. So far we've got all the sigma bonds. What about the pi bonds? Okay, so one of the things we have to note here is that this carbon in the middle is forming pi bonds with both of them. So let's do one at a time. So I'll use blue this time. So here, if this is in the plane of the board, right? So these two hydrogen and the carbon are all in the same plane, we can say, okay, this is going to be in the same plane of the board. And I just ruined my wonderful picture. So then that means that the pi bond, the unhybridized pi bonds that are overlapping are going to be perpendicular to this plane. So that means it's going to come out of the board and into the board. So again, I'm going to try to draw that the best I can. So I'm going to do that this way, like so. And so here, let me do that. And let me do this. Let me get this one kind of like that. That way might look better. So then this is going to overlap and this is going to overlap. So this is going in and out of the board. This is in the plane of the board. Now, what about this one? So this carbon is involved in pi bonding with this one, but this carbon already used one of its unhybridized p orbitals to form a pi bond. So it's going to have to use another unhybridized p orbital to form a pi bond, right? Because remember, this carbon here is sp hybridized. So it used an S and a P, so that means that leaves it 2 unhybridized p orbitals, right? So, but the thing to keep in mind is if this p orbital is going in and out of the board like this, perpendicular to the plane here, then the other unhybridized orbital for this middle carbon has to be perpendicular to this one, which means that this unhybridized, the second unhybridized p orbital is going to be perpendicular to this here. So it's going to be in the plane of the board because this unhybridized p orbital is coming out this way. So then the other unhybridized p orbital has to go up and down in the plane of the board. So let's use green for this one. So that means this other unhybridized p orbital is up and down in the plane of the board, above and below, which means that this one also is going to be above and below, right? Which means that these two hydrogens can't be up and down. They have to be in the plane because that means that this plane here that I drew is actually not like that. It's going to be perpendicular like this. So I need to then kind of draw this the best that I can to show that perpendicularity. So then this one I can kind of go a little smaller in that way, and then this one's going to come out that way. So then this is going to be closer, this is going to be farther away. So I have my hydrogen here, I have my hydrogen there. So hopefully that kind of looks like it's this way. And then this is going to overlap above the plane. This is going to, oops, I should make this the same. This is going to overlap below the plane. So now hopefully this looks better. And so now what's going to happen is that these two hydrogens are in the plane of the board. These two hydrogens are perpendicular to the plane of the board. This hydrogen is coming out of the board. That hydrogen is going into the board. So these hydrogens are not like this. They're not like this. They're like this. So they are perpendicular to each other. And so that gets to our question here. For molecule C above this one here, do all four hydrogen atoms lie in the same plane? If they were in the same plane, they would be like that, but that is not possible given the fact that we have two pi bonds, a pi bond over here overlapping, a pi bond over here overlapping. And if we understand that overlapping pi bonds, or I should say pi bonds, are the result of overlapping unhybridized p orbitals, and that p orbitals are perpendicular to each other, then these cannot be in the same plane as those. They have to be perpendicular to each other. So that is the answer to the question. So the spatial relationship, what is the spatial relationship of these four hydrogens? They are perpendicular to each other. And that, ladies and gentlemen, is the end of this video. I hope this helped you out a lot. I hope this was clear. I apologize for my awful drawings, but I hope they're good enough to show you what you want to do in your drawings. So if this helped you out, if you learned a lot from this video, then please share the video, like the video, hit that like button somewhere over here. You can find it somewhere. Also, do me a favor, help me out. Subscribe to my channel, hit that notification bell. When you do, make sure you click all so you can be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have any question that you need help with or a problem that you need help with, let me know. If you have a topic that you want me to cover, let me know. Put that down below. I would love to do that for you. Thanks for joining me and have a great day.